Ever wake up on a winter morning and think, whoa, it's freezing? The kind of cold that makes you want to dive back under the covers and hibernate until spring. It's the kind of chill that seems to seep into your bones, making you wonder just how cold it can get. Maybe you've heard the news mention the polar vortex, a name that sounds like a comic book villain. It's often portrayed as this menacing force, but what is it really? But the polar vortex isn't a monster. It's a powerful part of our planet's weather system, and it's why some winters get so cold. It's a swirling mass of frigid air that usually stays put, but sometimes it decides to wander. Today, we're unraveling the mystery of the polar vortex, what it is, where it lives, and why it sometimes sends Arctic air our way. It's like a giant air conditioner that occasionally malfunctions, sending icy blasts far and wide. Picture it as a giant spinning top of cold air, usually minding its own business up north, until it wobbles and sends a blast of chill south. This wobble can lead to dramatic weather changes affecting millions. Understanding this helps us see how our world works, from school closures to frozen pipes. It's not just about bundling up, it's about understanding the forces at play. We'll use simple ideas, like spinning tops and wobbly fences, to make it all clear. These analogies help us grasp the complex dance of air currents and temperatures. By the end, you'll be able to explain the polar vortex to anyone, and you'll know about its sidekick, the jet stream. This fast-flowing river of air plays a crucial role in steering the polar vortex. We'll even look at real-life examples and how climate change might be stirring things up. As our planet warms, these weather patterns could become more unpredictable. Everything's connected, from the top of the atmosphere to your winter boots. The layers of the atmosphere interact in ways that impact our daily lives. So, let's dive into the science behind winter's wild ride. Together, we'll explore the fascinating interplay of forces that make winter both beautiful and challenging. First, let's clear this up. Despite what you might hear on the news, the polar vortex isn't a storm like a blizzard, hurricane, or even a typical winter storm. It's not something that suddenly appears and then disappears. Instead, it's a much larger, more persistent feature of our planet's atmosphere. The polar vortex is actually a massive, permanent pool of super cold, low-pressure air that sits high above the Earth's poles. There are two of them, one swirling over the North Pole and another over the South Pole. These aren't just small pockets of cold, they're enormous, stretching thousands of kilometers across. For most of us, it's the northern polar vortex that matters most, since it can influence weather across North America, Europe, and Asia. Picture a gigantic, invisible bowl of icy air spinning steadily in the stratosphere, which is the layer of the atmosphere about 10 to 50 kilometers above the ground. This isn't where our weather happens, but it has a huge impact on what we experience down below. During the long, dark winter months, when the pole receives no sunlight at all, this air gets even colder and denser. The vortex spins faster, becoming more stable, almost like a perfectly balanced top whirling in place. The polar vortex acts as a kind of climate gatekeeper, keeping the coldest air locked up over the Arctic. It forms a boundary that usually prevents this frigid air from spilling south into lower latitudes. So, when you hear the term polar vortex, don't picture a single storm cloud. Instead, imagine a vast, rotating dome of frigid air, stretching high above the Arctic, quietly influencing the weather far below. This system is always up there, spinning silently and steadily, even when we don't notice it. But the real drama begins when this stable system gets disturbed by things like sudden warming events in the stratosphere or shifts in the jet stream. When the polar vortex loses its stability, the cold air it was holding back can break free, spilling southward in dramatic fashion. That's when we feel its power. Temperatures can plummet, and winter weather can arrive suddenly and fiercely, all thanks to the polar vortex letting go of its icy grip. If the polar vortex is a pool of cold air, what keeps it from spilling out? Enter the jet stream, a fast-moving river of air in the troposphere, our weather's playground. Think of the jet stream as an invisible fence, separating cold Arctic air from warmer southern air. When the temperature difference between north and south is big, the jet stream is strong and straight, keeping the polar vortex contained. It's like a tight fence holding bouncy balls in place. A strong jet stream means predictable winters. Cold stays north, warmth stays south. But if the fence weakens, if the temperature difference shrinks, the jet stream gets wavy and slow. Those big, loopy waves are the key to understanding how Arctic air escapes. When the jet stream wobbles, the cold can break free. That's when the polar vortex makes headlines. The wobbly fence can't hold back the chill. And that's when winter gets wild. So, what happens when the jet stream weakens and gets wavy? Those big waves let cold Arctic air spill south. This isn't the whole vortex moving, just a lobe of frigid air breaking away and plunging into places like Chicago or Boston. Imagine poking a spinning blob of jelly. A piece stretches out and brings the deep freeze with it. This air has been chilling in darkness over the pole, so when it escapes, it's dangerously cold. That's why temperatures can drop by dozens of degrees in a day, causing wind chills and life-threatening conditions. While one area freezes, another might be unusually warm. The jet stream's waves create both cold troughs and warm ridges. So, as Chicago shivers, Alaska might be having a heat wave. It's all part of the same atmospheric imbalance. A wobbly jet stream means extreme weather contrasts. The polar vortex's reach is global, and it all starts with a simple wobble. What makes the polar vortex wobble, sending icy blasts far beyond the Arctic? The answer lies in a dramatic atmospheric event that can shake up weather patterns across the globe. One big culprit: sudden stratospheric warming, or SSW. This rare phenomenon is a game-changer for winter weather. During SSW, the stratosphere over the North Pole can heat up by as much as 50 degrees Celsius in just a few days. This rapid temperature spike is a true shock to the system, disrupting the usual flow of air high above the Earth. But this warming doesn't come from the sun. Instead, it's caused by powerful atmospheric waves, giant ripples of energy, rising up from the lower atmosphere and crashing into the stratosphere. When these waves break, they unleash bursts of energy, rapidly warming the stratosphere and throwing the polar vortex off balance. Picture the polar vortex as a spinning top. If you blast it with a gust of warm air, it starts to wobble, slow down, or even split apart. The same thing happens in our atmosphere. SSW can weaken or even shatter the vortex into smaller, less stable pieces. These fragments are much more likely to drift southward, carrying frigid Arctic air with them. The effects don't happen overnight. It usually takes a week or two for the disruption to reach us, but when it does, the jet stream becomes wavy and unpredictable, letting cold air spill far to the south. That's why meteorologists keep a close eye on SSW events. They serve as an early warning system, giving us a heads up that a deep freeze could be on the horizon. When SSW is detected, it's a signal that extreme cold and winter storms could soon be on the way, affecting millions of people. The stability of the polar vortex is surprisingly fragile, easily disrupted by these powerful atmospheric forces. And when the vortex is thrown off balance, we feel the consequences. Sometimes in the form of record-breaking cold, snowstorms, and winter chaos that can impact our daily lives in dramatic ways. Polar vortex events have real dramatic impacts. In early 2019, a major disruption sent Arctic air deep into the Midwest and Northeast U.S. cities like Chicago hit -23 degrees Fahrenheit, with wind chills near -52, colder than Antarctica. Schools closed, flights were canceled, and even mail delivery stopped. Infrastructure strained, pipes burst, power grids struggled, and train tracks were set on fire to keep them from breaking. People shared videos of boiling water turning instantly to ice. These events remind us that understanding the polar vortex isn't just science, it's survival. Knowing how to prepare can make all the difference. So, is climate change involved? Surprisingly, yes. The Arctic is warming twice as fast as the rest of the planet, a process called Arctic amplification. This shrinks the temperature difference that powers the jet stream, making it weaker and wavier. A wavier jet stream lets more cold air escape south, causing intense cold snaps even as the planet warms. Think of the Arctic as a fridge. As it warms, the seal, jet stream, weakens, letting cold air leak out. Not every cold snap is caused by this, but the evidence is growing. A warming Arctic is changing our weather patterns, leading to more extremes, hot and cold. Our climate system is full of surprises. What about the southern polar vortex? It spins over Antarctica and is even stronger and more stable than its northern sibling. Why? Geography. Antarctica is a massive, high-altitude continent surrounded by ocean, making for a stable, cold environment. The northern vortex sits over a mix of ocean and land with mountains that disrupt airflow and create waves. The southern ocean has no such obstacles, so the southern vortex rarely wobbles. That's why Antarctica stays much colder than the Arctic, and you don't hear about polar vortex events in the southern hemisphere. The southern vortex is also famous for the ozone hole. Its stable, cold conditions create clouds that help destroy ozone when the sun returns in spring. The strength of the southern vortex makes this process efficient. Geography shapes our climate in powerful ways. The polar vortex isn't a monster, it's a normal, fascinating part of Earth's atmosphere. When stable, it keeps the coldest air locked away. When disrupted, it brings record-breaking cold. Sudden stratospheric warming and a wobbly jet stream can open the freezer door, sending Arctic air south. Climate change is making these disruptions more common and unpredictable. Understanding the polar vortex helps us see the big picture, how everything in our climate is connected. From spinning domes of air to city-wide deep freezes, it's science in action. Next time you hear polar vortex, you'll know the story behind the chill. That's the power of science, making sense of our amazing, ever-changing world.